If I told you dinosaurs never really disappeared, would you believe me? Tonight on Science for Sleeping, we'll uncover how these ancient giants paved the way for birds, flapped their feathered wings into the modern world, and how their legacy still lives all around us. The story of extinction may not be what you think. The world dinosaurs inherited. Imagine stepping into a world so stripped of life, so hostile, that survival itself felt like an impossible task. This was Earth over 250 million years ago, during a time called the Permian-Triassic extinction, or as some call it, the Great Dying. It wasn't just a catastrophe, it was the most devastating mass extinction in our planet's history. Nearly every living thing, from plants to animals, vanished. In fact, over 90% of all marine species were wiped out, and about 70% of species on land followed them. It was an age where silence stretched across the planet, broken only by the rumble of volcanic activity and the howl of toxic winds. You'd find vast stretches of volcanic wastelands, belching gases into a fragile atmosphere. These massive eruptions, tied to what's called the Siberian Traps, a gigantic region of volcanic rock, pumped carbon dioxide and other gases into the air. Temperatures rose, then fell sharply. The climate swayed between extremes, and the oceans, once teeming with life, turned sour and lifeless. At a glance, it might seem like the planet was broken beyond repair, incapable of supporting anything beyond the most basic forms of life. For millions of years after the Great Dying, the Earth remained a challenging place. Oxygen levels had plummeted so much that even the air itself would have been difficult to breathe. Plants, which fuel the foundational links of ecosystems, were slow to spread back across barren landscapes, leaving little food for any animal daring enough to evolve. It was as if the very mechanisms that made Earth habitable were stalled, dragging their feet toward recovery. And yet, life didn't just give up. This is the part of the story where the survivors step forward. Some species clung to existence in these extreme conditions, barely scraping by in small, isolated groups. Among these, a peculiar lineage of animals began to emerge, creatures that, despite all odds, started adapting to the chaos. These were the archosaurs, known as the ruling reptiles, and they were no ordinary survivors. They were the ancestors of dinosaurs, crocodiles, and even birds. At first glance, archosaurs looked unassuming, like small lizards with long tails and slender legs. But appearances don't tell the whole story. Even in the early stages of their evolution, these creatures had traits that allowed them to tackle the harsh world they inherited. Take something like Euparkeria, one of the first archosaurs. Standing about the size of a modern-day house cat, it had long legs positioned beneath its body, rather than sprawling out to the sides like a lizard of today. This upright posture let it move quickly and efficiently, an advantage in a world where you'd need to cover ground fast, either to find food or to avoid becoming food yourself. What's more, evidence suggests it might have had some degree of warm-bloodedness, which means it could stay more active in cooler temperatures when other creatures slowed down. This ability to do more with less oxygen, less energy, less food, was a crucial innovation. While other reptiles struggled under the low oxygen conditions of post-apocalyptic Earth, archosaurs seemed to thrive. Their bodies were built for endurance, and their metabolism allowed them to make the most out of scarce resources. They weren't just enduring this desolate world, they were figuring out how to dominate it. But what made archosaurs stand out wasn't just their ability to adapt, it was their potential for change. They were versatile, and over time, some members of this group began pushing the boundaries of evolution. It was as though these early archosaurs acted as nature's workshop, experimenting with different traits and possibilities. Some became the forerunners of today's crocodiles, while others, smaller, faster, and more agile, would eventually become the dinosaurs. Here's the thing. It's easy to look back and admire their resilience, but surviving this period wasn't glamorous or easy. The early Triassic world was still dangerous and unpredictable. There weren't lush forests or sprawling plains yet. Instead, there were vast stretches of dry, cracked earth where plant life clung to life in patches. Rivers and lakes appeared only sporadically, tempting animals with brief oases that often dried up just as quickly. Within this testing ground, these small archosaurs had to strategize. They relied on speed to hunt or evade, using their upright stance to leap or sprint. Their teeth suggest they ate whatever they could find, from plants to insects or even smaller animals. It's possible the keen eyesight seen in their descendants helped them hunt as well as avoid enemies. Over thousands upon thousands of generations, these survivors weren't just adapting, they were setting the stage for something remarkable. This transformation wasn't something anyone or anything could predict. But step back for a moment and consider the bigger picture. These traits, upright posture, hints of warm-bloodedness, adaptability to harsh climates, weren't just minor tweaks for survival. They were building blocks. Nature was slowly assembling the tools that would later spark one of the most successful reigns in Earth's history, the Age of Dinosaurs. Archosaurs weren't just survivors of a disaster. They became pioneers. Their ability to innovate under pressure didn't just secure their immediate future. It laid the blueprint for an entirely new era of life. And before long, a small, relatively unnoticed group of them began to evolve in even stranger, more experimental directions. These weren't simply archosaurs anymore. They were dinosaurs. Now, take a moment to imagine the fragility of that leap. It's easy to think of dinosaurs as unstoppable giants. But when they first appeared, they were unassuming, small, and far from dominant. For now, we'll leave that moment in history perched on the edge, where the first dinosaurs were just beginning to find their footing in a changed world. Their rise was anything but certain, and their story was just getting started. Dinosaurs take their first steps. What if the secret to dominating the prehistoric Earth began with something as simple as a step? Around 230 million years ago, during the middle of the Triassic period, the first true dinosaurs emerged. They weren't towering giants or apex predators yet. In fact, in their early days, they were small, agile creatures navigating a world teeming with rivals. Imagine Eoraptor, one of the earliest dinosaurs we found, standing barely the height of a dog, lightweight and built for speed. It darted through the dense vegetation, sharp teeth flashing, likely preying on insects, small animals, or whatever it could catch. Then there was Herosaurus, another early contender, slightly bigger with a powerful jaw and long predator-like teeth. These weren't creatures that ruled the land outright, but they were distinctly different. They were the smallest embers of what would become a fiery dynasty. The world back then was no easy place to make a mark. This was a landscape crowded with competitors, from other archosaurs to the mighty synapsids, ancestors of mammals and even massive amphibians. These weren't slow, lumbering animals either. Many evolved to thrive in this complex and evolving ecosystem. Early dinosaurs had to carve out a space for themselves amid this chaos, where the rules of survival weren't decided by size alone, but by physique, behavior, and an ability to adapt to a challenging environment. So, what gave dinosaurs their first real edge? The answer lay, oddly enough, in how they held their bodies. Picture most reptiles today, like lizards or crocodiles, and one thing stands out. Their legs stick out to the sides, sprawling awkwardly as they crawl or run. This posture may work for short bursts of motion, but over longer distances it's slower and more tiring. because the energy expended is lost to inefficient movement. Early dinosaurs were different. Their legs were positioned directly beneath their bodies, almost like stilts, lifting them higher above the ground as they walked or ran. This upright stance made their movements far more efficient. They could run faster, cover greater distances, and conserve energy while doing so. This one evolutionary tweak gave them a head start in leaving many rivals, quite literally, in their dust. But movement was only part of the equation. Think about the conditions of the time. The Triassic was still clawing its way back from the devastation of the Great Dying, and oxygen levels in the atmosphere were significantly lower than they are today. Simply breathing was a challenge for many animals, especially larger ones that required more energy to survive. Yet, dinosaurs didn't struggle in this way, and their secret weapon had everything to do with how they breathed. They likely had a respiratory system strikingly similar to that of modern birds, equipped with air sacs. If you're not familiar with their function, these air sacs allow for a continuous flow of oxygen through the lungs, ensuring there's always fresh air moving through the system. While many of their competitors had to stop or slow down frequently to catch their breath, dinosaurs could keep going, maintaining energy over longer periods of time. In a world with limited oxygen, this wasn't just an advantage, it was a game changer. These respirational innovations also freed them up to explore niches that other creatures couldn't. Early dinosaurs were small and nimble, which allowed them to weave into environments where the bulkier members of the ecosystem couldn't compete. Some may have hunted in open plains or forests, others scavenged or foraged in environments less accessible to other animals. Over time, these opportunistic tendencies allowed dinosaurs to flourish in ways that weren't immediately obvious, but would pay off dramatically as history unfolded.
All of this paints the picture of a creature that seemed well prepared to thrive. But it's important to understand they weren't invincible. In this early period, dinosaurs were just one group among many. They weren't dominating the Earth yet, and they weren't immune to the same pressures facing every other species around them. Despite their biological advantages, the Triassic landscape still posed immense dangers. Larger predators from rival groups hunted them just as ferociously as they hunted smaller prey. It would have been an era of constant tension, where survival depended not just on biology, but also luck and timing. Timing, it turns out, was about to throw some unexpected help their way. As the Triassic period drew to a close, Earth was about to experience another moment of upheaval. Another mass extinction event loomed on the horizon, about 201 million years ago. This wasn't a cataclysm on the same scale as the Great Dying, but it was significant enough to obliterate many of Earth's dominant species, including quite a few major competitors to these early dinosaurs. The reasons behind this extinction are linked to massive volcanic eruptions, which altered the climate, released large amounts of greenhouse gases, and triggered dramatic environmental changes. When the dust settled and the air cleared, the world looked very different, and those who could quickly adapt found themselves with opportunities they'd never had before. And, as luck would have it, dinosaurs were uniquely positioned to step into this open world. Their upright posture, efficient respiratory systems, and adaptive strategies had given them the tools they needed. No longer were they tiny underdogs scrambling for survival in a crowded ecosystem. They were becoming the dominant force, shaping the trajectory of life on Earth. Their foothold would only strengthen as they evolved into the Jurassic period's larger and more diverse forms. For now, however, they remained small by comparison to their future descendants, quietly expanding their role in the evolving ecosystems around them. Reflecting on this period, it's striking how small changes gave rise to such monumental outcomes. A slight adjustment in posture, a more effective way of breathing, and a knack for flexibility in harsh conditions were, individually, small innovations, seemingly insignificant. But together, they created a lineage so capable
that even mass extinctions couldn't hold them back forever. These early dinosaurs were fast, efficient, and already rewriting the rules of survival. And yet, at this point in their story, they were still waiting for their breakout moment. That moment wasn't far off. With their competition thinned and new ecological spaces to fill, the dinosaurs began to rise in earnest. What came next was an explosion of forms, sizes, and strategies that not only elevated them to dominance, but turned them into some of the most iconic creatures in the history of life on Earth. To truly understand what made them such unrivaled rulers, we'll need to step into the Jurassic, the Age of Giants. But for now, remember this: the dinosaurs' journey started small, with quiet steps and clever adaptations that prepared them for a world they'd soon claim as their own. The Jurassic boom. Giants take over. The Jurassic period was a time of abundance, where the Earth's warm, humid climate created vast expanses of greenery. It was a world brimming with opportunity, layered with lush forests of ferns and cycads. Around 200 million years ago, as the Triassic gave way to the Jurassic, dinosaurs began taking full advantage of this fertile environment. For millions of years, they had hovered at the edges, small, light-footed survivors just scraping by. But in this new phase of Earth's history, something remarkable happened. They began to grow, in every sense of the word. The biggest stars of this Jurassic boom were undoubtedly the sauropods, those towering, long-necked giants that seemed to defy biology itself. Names like Apatosaurus, Diplodocus, and Brachiosaurus might sound familiar, but even their sheer scale is hard to wrap your head around. Take Diplodocus, for instance. Stretching over 80 feet long, its body was like a biological marvel of streamlining. Lightweight bones, an incredibly long tail for balance, and a neck that extended high into the treetops. Then there was Brachiosaurus, whose neck reached even higher, grazing on vegetation other dinosaurs could scarcely dream of reaching. These sauropods were like the giraffes of their world, engineered by evolution to specialize in harvesting the Jurassic forests. Now, what's truly astonishing is how these massive creatures pulled it off biologically. After all, carrying several tons of weight is no easy feat, even for an animal. Sauropods relied on an array of adaptations to grow and move on such an epic scale. Their bones, surprisingly enough, weren't as heavy as you'd think. They were structured with air-filled spaces, similar to the bones of modern birds, which kept their skeletons light but strong. Imagine holding a bone that's nearly the size of a car, but not nearly as heavy as it looks. This hollow design was key to achieving their enormous size without collapsing under their own weight. Then there was their unique breathing system. Sauropods had an efficient respiratory mechanism, again much like birds today, with air sacs that let them circulate oxygen constantly. This wasn't just convenient, it was essential. For animals their size, relying on a standard in-and-out breathing pattern wouldn't have been enough to supply the energy their bodies demanded. Their air sacs gave them a continuous flow of fresh oxygen, keeping their massive frames fueled and active. But growing large wasn't just about reaching the highest branches or sipping oxygen like a pro. It also had a lot to do with survival. Being gigantic had its advantages. It was an incredible defense against predators. Sure, you had sharp-toothed carnivores like Allosaurus patrolling the Jurassic landscape, but how often do you think one would risk attacking a fully grown sauropod? Even the hungriest predator has to think twice before taking on an animal that could crush it with one swing of its tail. That said, it wasn't all perfect security. Younger and smaller members of sauropod herds were vulnerable to attacks, and some predators had strategies to exploit this weakness. Speaking of predators, Allosaurus deserves its own moment of recognition. This apex predator of the Jurassic era was a master of its craft, sleek and deadly. Reaching lengths of up to 30 feet, Allosaurus wasn't the largest predator in history, but its adaptations made it something far more dangerous than sheer size ever could. Its skull was filled with serrated teeth, perfect for slicing through flesh, while its strong forelimbs tipped with sharp claws made it an efficient killer. While some paleontologists believe it might have hunted alone, there's evidence suggesting it may have worked in groups. Coordinated attacks wouldn't just make sense. It would make Allosaurus even more formidable, allowing them to take down larger herbivores or prey that would have been off limits to solitary hunters. Don't let the focus on sauropods and predators fool you into thinking the Jurassic period was all about conflict, though. These dinosaurs weren't just surviving, they were reshaping the world around them. Sauropods, in particular, played an enormous role as ecosystem engineers. Picture this: a herd of Apatosaurus slowly moving across an ancient floodplain, tearing through vast quantities of plants, stripping low-hanging branches, and stomping trails into the soil. They consumed hundreds of pounds of vegetation every single day, acting like natural lawnmowers, clearing out vegetation and creating space for new growth. Their droppings, meanwhile, helped fertilize the soil, spurring the regrowth of plants and maintaining balance in their ecosystems. These weren't just animals living in their environment, they were actively transforming it, shaping the Jurassic landscape in ways that benefited not only themselves, but countless other species as well. Another fascinating aspect of this era was how social behavior began to emerge more prominently among some dinosaur species. Evidence such as trackways preserved in ancient mud hints that many dinosaurs likely traveled in herds. This wasn't just a practical strategy for protection or finding food. It was a sign of increasingly complex behaviors evolving. Traveling in groups might have allowed sauropods to migrate to new feeding grounds more efficiently, while predators like Allosaurus could potentially coordinate their attacks. It's one of the many signs that the Jurassic wasn't just an age of physical giants, but intellectual innovation as well. Dinosaurs weren't just surviving, they were thriving, experimenting, and pushing the boundaries of what was possible in their time. But as idyllic as this world might sound, the Jurassic wasn't static. It was a time of shifting landscapes and geological change. The supercontinent Pangaea, which had dominated earlier periods, was beginning to break apart. Pieces of land were drifting slowly away from each other, creating new coastlines and isolated environments. These separations introduced new challenges and new opportunities. As populations of dinosaurs became geographically isolated, their evolutionary paths diverged, leading to more specialization and diversity. Over time, the species that thrived in the lush forests of one region would look very different from those adapted to desert-like conditions elsewhere. This diversity is one of the signature features of the Jurassic. On one hand, you had giants like Brachiosaurus that were designed to exploit towering vegetation, and on the other hand, you had small, nimble dinosaurs scurrying beneath them, living in a totally different ecological niche. And within this mix, predators like Allosaurus and herbivores like Stegosaurus occupied their own corners of this thriving ecosystem. It was a time when the balance of life was continually shifting, with each species playing a role in the larger drama of survival. By the end of the Jurassic, dinosaurs had achieved levels of success that were unprecedented, not just in size, but in their sheer diversity and innovation. They were masters of land and had a presence that stretched into the skies as feathered creatures began experimenting with flight. What truly started as an age of giants had grown into an age of ecosystems, full of dynamic interactions that would continue to evolve long after the Jurassic ended. But nothing stays the same forever. As the continents continued to drift apart and the Cretaceous period loomed on the horizon, dinosaurs faced new challenges and opportunities. Diverse as they had already become, they were about to see an explosion of innovation like never before. The breakup of Pangaea, the arrival of flowering plants, and the continued rise of small, agile dinosaurs would push evolution to its most creative extremes.
The Age of Dinosaurs was just hitting its stride, and what came next was nothing short of spectacular. For now, though, it's worth pausing to appreciate the Jurassic, a time when giants ruled, ecosystems flourished, and dinosaurs cemented themselves as the undisputed rulers of the land. Every towering tree, every booming footstep, every beating heart, it all spoke of life thriving in ways that seemed unimaginable just millions of years before. Feathers, flight, and the first birds. Feathers on dinosaurs. It sounds strange at first, doesn't it? But millions of years ago, long before flight was ever an option, feathers were already making their debut. These weren't the sleek, aerodynamic feathers we see on birds today. Instead, they ranged from simple, fuzzy filaments to more complex structures, and they weren't meant for soaring through the air, at least not yet. Feathers came about for other, more grounded purposes, and in doing so, they quietly reshaped what it meant to be a dinosaur. One of the most fascinating fossils ever discovered is Archaeopteryx. Found in the 19th century, it's often called the first bird, though it's technically more of a bird-like dinosaur. This ancient creature was a vivid mix of traits. Its wings and feathers give it a strikingly bird-like appearance, complete with a wishbone to anchor powerful flight muscles, something birds still use today. But the rest of its body clings to its reptilian ancestry. It had teeth instead of a beak. Its long, bony tail stretched out behind it, balancing its body in ways modern birds no longer need. Even its wings, so reminiscent of birds, still had clawed fingers halfway down the structure. If you picture it trying to take off, you'd see something caught between two worlds. Whether Archaeopteryx could truly fly like a bird is still up for debate, but it likely could flutter between trees or glide over short distances. Even at this halfway point in evolution, it was an extraordinary glimpse of transformation in action. But nothing stays the same forever. As the continents continued to drift apart and the Cretaceous period loomed on the horizon, dinosaurs faced new challenges and opportunities. Diverse as they had already become, they were about to see an explosion of innovation like never before. The breakup of Pangea, the arrival of flowering plants, and the continued rise of small, agile dinosaurs would push evolution to its most creative extremes. The Age of Dinosaurs was just hitting its stride, and what came next was nothing short of spectacular. For now, though, it's worth pausing to appreciate the Jurassic, a time when giants ruled, ecosystems flourished, and dinosaurs cemented themselves as the undisputed rulers of the land. Every towering tree, every booming footstep, every beating heart, it all spoke of life thriving in ways that seemed unimaginable just millions of years before. Feathers, flight, and the first birds. Feathers on dinosaurs. It sounds strange at first, doesn't it? But millions of years ago, long before flight was ever an option, feathers were already making their debut. These weren't the sleek, aerodynamic feathers we see on birds today. Instead, they ranged from simple, fuzzy filaments to more complex structures, and they weren't meant for soaring through the air, at least not yet. Feathers came about for other, more grounded purposes, and in doing so, they quietly reshaped what it meant to be a dinosaur. One of the most fascinating fossils ever discovered is Archaeopteryx. Found in the 19th century, it's often called the first bird, though it's technically more of a bird-like dinosaur. This ancient creature was a vivid mix of traits. Its wings and feathers give it a strikingly bird-like appearance, complete with a wishbone to anchor powerful flight muscles, something birds still use today. But the rest of its body clings to its reptilian ancestry. It had teeth instead of a beak. Its long,
bony tail stretched out behind it, balancing its body in ways modern birds no longer need. Even its wings, so reminiscent of birds, still had clawed fingers halfway down the structure. If you picture it trying to take off, you'd see something caught between two worlds. Whether Archaeopteryx could truly fly like a bird is still up for debate, but it likely could flutter between trees or glide over short distances. Even at this halfway point in evolution, it was an extraordinary glimpse of transformation in action.
Feathers like the ones Archaeopteryx had didn't magically appear for flight. In fact, long before birds or even the distant ancestors of birds existed, feathers were evolving in other dinosaurs. Their earliest forms were simple, almost hair-like strands that more likely resembled fuzz than feathers. These were perfect for insulation, especially for smaller dinosaurs that needed to retain body heat in chillier conditions. As these prehistoric creatures adapted to their environments, feathers became more specialized. Some dinosaurs began using feathers for display, sporting larger, brighter plumes to attract mates or intimidate rivals. Others may have relied on these proto-feathers for camouflage, their colors and patterns helping them blend into forests and open plains, much like today's animals rely on fur or scales to hide from predators or sneak up on prey. Over millions of years, feathers grew more elaborate. Imagine the theropods, two-legged, sharp-toothed dinosaurs and the ancestors of birds experimenting with their plumage. For some, feathers grew out into striking shapes, perhaps dazzling potential mates like a prehistoric version of peacocks. Others may have developed subtle patterns to blend into their surroundings, avoiding the gaze of watchful predators. Even though flight wasn't yet in the cards, feathers had already transformed life for theropods. And this world wasn't all shades of brown or gray. Researchers have discovered pigment structures in fossilized feathers, suggesting that some feathered dinosaurs had vivid colors, reds, yellows, blues, that might have made today's parrots or toucans look modest by comparison. Fast forward to the Cretaceous, when birds as we know them were starting to take shape and the function of feathers began shifting toward a new frontier: flight. Some theropods, like the ancestors of birds, were living lighter, faster, and more efficiently. Over time, the once functional feathers for warmth or display started doubling as flight tools. Archaeopteryx serves as a perfect example of this transition. Its wing feathers were asymmetrical, much like those of modern flying birds, which helped in creating lift necessary for flight. But flight itself wasn't the only use of feathers then, and it wasn't an ability all feathered dinosaurs shared. For many, feathers continued to play dual roles, adding warmth, providing visuals for display, or simply assisting with balance as they ran or climbed. This experimentation in feather evolution demonstrates how versatile a single trait can be over millions of years.
During the Cretaceous, this transition became even clearer, with birds like Ichthyornis and Hesperornis. These were early birds, but they didn't look identical to those flying around today. Ichthyornis, for example, was a strong flyer, with a body that might remind you of a modern seabird. But up close, its toothy jaws would have made it clear that it was still carrying some dinosaurian traits. Evolution had taken bold steps toward the bird profile we recognize now, but it hadn't quite left the Mesozoic behind. On the other hand, Hesperornis went in a different direction entirely. It was flightless, adapted instead for a life of diving and hunting in marine environments. Its body resembled a mix between a loon and a reptile, a swimmer rather than a flyer. These two early birds illustrate just how experimental this period was. Some lineages were perfecting flight, while others abandoned it altogether to dominate new, watery worlds. One of the biggest milestones during this time was the gradual shift from toothy jaws to beaks, an adaptation that would become one of the defining features of modern birds. Teeth, while useful, are dense and require a lot of energy to maintain. Beaks, by contrast, are lightweight and could be specialized for different diets, nipping at seeds, cracking nuts, or slicing through prey. This change further separated early birds from their theropod relatives
and gave them yet another advantage in a world full of varying ecological niches. It's a small detail that made an enormous difference for survival, especially after the mass extinction event that would wipe out most dinosaurs. What's striking is how these early birds weren't a separate story from dinosaurs. They were part of it. Every feather, every flapping wing, every new beak shape was a continuation of the dinosaur lineage. When you think of a creature like Archaeopteryx perched on a Jurassic branch, or a Cretaceous bird swooping over a coastline, you're not looking at the after of dinosaurs. You're still looking at dinosaurs. It's just that this group discovered a different way to thrive. While all of this was happening in the air, many dinosaurs on the ground were innovating in entirely different directions. Large predators and armored herbivores were adapting to the environment in incredible ways, but they weren't experimenting with feathers or taking to the skies. Instead, they were mastering their dominion over the Earth's vast landscapes. Feathers, for them, remained evolutionary sidelines, irrelevant to their success. And yet, the rise of feathers within certain theropod groups tells us something deeper about evolution itself. It reminds us that the same trait can be bent and reshaped for completely different purposes, depending on what survival demands.
By the time the Age of Dinosaurs drew to a close, feathers had gone from humble insulation to one of evolution's greatest success stories. They provided warmth, they dazzled potential mates, they camouflaged predators, and finally, they lifted creatures into the air. What started as small, simple structures became tools for rewriting the rules of life during the Mesozoic era. Feathers weren't just an adaptation, they were a gateway into a new world of possibilities, paving the way for birds to spread far beyond what dinosaurs ever could. But even as some dinosaurs were soaring into the skies, the diversity of life on the ground remained just as fascinating. Evolution doesn't follow a single path, and the next chapter in this story, the rise of incredibly specialized forms during the Cretaceous, would show how unpredictable and innovative life could be. As feathers transformed the skies, the land was undergoing its own extraordinary changes, with dinosaurs continuing to adapt in ways that would push evolution to its limits. So while it's tempting to say feathers were the stars of this period, they were really just one thread in a much larger tapestry of life, and what came next would only make that picture more impressive. The Cretaceous, dinosaurs' golden age.
What happens when evolution gets 80 million years to try, fail, and surprise itself? That's the Cretaceous period, the golden age of the dinosaurs. This wasn't just a time of big predators and bigger herbivores. It was a world bursting with incredible variety. Dinosaurs didn't just come in new shapes and sizes. Their ecosystems stretched from dense forests to sweeping deserts, running wild with evolutionary experiments. At the same time, the Earth itself was changing underneath them. The supercontinent Pangaea was splitting apart, and for the first time in millions of years, species began to live in regions completely isolated from one another. This created more opportunities for life to branch out, evolve, and adapt to completely unique environments.
Take the ceratopsians. These dinosaurs might be the first thing you think of when you hear the word dinosaur. Giant, intimidating, with horns jutting from their heads. But they were so much more than prehistoric tanks. Dinosaurs like Triceratops or Styracosaurus didn't just happen. They were a product of constant change, molded by a need to survive in new, fragmented environments. Ceratopsians were built to take on anything. Their short, sturdy limbs could carry bodies the size of small trucks, and their beak-like mouths were perfect for gripping and slicing through tough plants. Their real signature, though, was their skulls. Frills, horns, and spikes adorned their heads, forming some of the most elaborate armor evolution ever produced. Some of those horns were likely used as weapons, a way to keep predators at bay. But it's likely the frills weren't just practical. They were also display-worthy. Brightly colored or patterned, those decorative frills might have been the ceratopsians' way of attracting mates or distinguishing one species from another. Then there were the ankylosaurs, the literal walking fortresses of the dinosaur world. Imagine something that looked like a living tank, low to the ground, covered in thick, bony plates, and bristling with spikes. Ankylosaurs were evolution's answer to the question, how much armor is too much? They even carried specialty weapons. Certain species, like Ankylosaurus, had bone-crushing clubs attached to the ends of their tails. With one swing of that club, they could break the legs of any carnivore reckless enough to attack them. It's hard to imagine a predator seeing an ankylosaur and thinking, yeah, I could take that. And if you think being massive and armored was the only way to thrive during the Cretaceous, then the hadrosaurs might surprise you. Known as duck-billed dinosaurs, they were the exact opposite of the ankylosaurs in many ways. These were some of the most adaptable herbivores of the age. Hadrosaurs were versatile grazers, feasting on a variety of plants thanks to their incredibly complex dental structure. Their mouths were lined with rows of small, tightly packed teeth, hundreds of them, that could grind through almost anything from woody plants to seeds. But the real showstopper was the crests that crowned some hadrosaurs' heads. Enormous, hollow, and sometimes curving in fascinating shapes, the crests weren't just for looks. They acted as resonating chambers, turning the dinosaurs' calls into deep, eerie sounds that traveled far across open plains. These calls may have been used for communication between herds, warning signals, or even during mating displays. And they weren't just some silent dinosaurs wandering alone. These were social animals. They traveled in herds and even nested in groups, raising their young in communities.
Most of these herbivores needed all the advantages they could get because the predators stalking them were evolving just as fast. Chief among them, of course, was Tyrannosaurus rex. The name alone has a way of capturing attention, and for good reason. The T-Rex is an icon of predation in its purest form. Its skull alone was over 4 feet long, filled with banana-sized teeth capable of biting straight through bone. While its arms get a lot of jokes for being small, they didn't need to be large. Its immense jaw and powerful legs did all the real work. In fact, T-Rex relied on its excellent sense of smell and sharp vision to track prey over long distances, striking with deadly accuracy. And yet, even apex predators like T-Rex were part of a larger, interconnected world. They weren't just terrifying hunters. They were also opportunistic scavengers, ready to feast on whatever leftovers the ecosystem presented. The Cretaceous wasn't just shaped by the dinosaurs roaming across its landscapes. Plants, too, were undergoing a revolution. Until this point, the Earth's greenery had largely been dominated by conifers and cycads, plants that aren't flowering. But during the Cretaceous, flowering plants, or angiosperms, exploded onto the scene, quickly reshaping every ecosystem they touched. Instead of plain green trees and shrubs, flowering plants added pops of color to the environment. They began producing fruits, seeds, and nectar, which not only supported new kinds of insects, but also ushered in shifts in the diets of many herbivores. For a dinosaur relying on tough plants, this change meant access to entirely new kinds of food. Over time, preferences for flowering plants likely drove herbivores, including hadrosaurs and ceratopsians, to adapt their digestive systems further. What we sometimes call the Age of Dinosaurs could just as easily be called the Age of Plants having their moment, because this botanical revolution fundamentally changed the way dinosaurs ate, interacted with their habitats, and even shaped their own evolution. The land wasn't the only place where dinosaurs thrived. The skies and seas held their share of stunning life forms. Though birds were beginning to find their place among flying creatures, the skies weren't exclusively theirs yet. Pterosaurs, enormous winged reptiles, still ruled the skies during this time, with species like Quetzalcoatlus reaching wingspans up to 33 feet. Meanwhile,
The ocean swarmed with marine reptiles like mosasaurs, which weren't dinosaurs but shared the Earth's stage with them. The Cretaceous was alive in every direction you looked.
It's easy to see why this era is often called the dinosaurs' golden age. They weren't just hanging on, they were conquering every corner of the planet. Ceratopsians dominated the plains with their fearsome frills. Ankylosaurs turned defense into an art form, hadrosaurs roamed in massive herds, and theropods imposed fear across every ecosystem they entered. As the continents continued drifting apart, these species only grew more specialized. Populations isolated on separate landmasses adapted to new challenges and climates, splitting off into distinct evolutionary lines. The diversity of the Cretaceous is what really stands out. This wasn't a world of one or two star dinosaurs hogging the spotlight. It was a kaleidoscope of life. Each species, whether predator or prey, filled its own role in a delicate balance. Different regions had entirely different ecosystems driven by the geography, climate, and even plant life that had taken root there. This constant experimenting and evolution created a stunning variety of creatures, each with its own adaptations to survive the challenges of the Cretaceous world. But beneath all this success, something was quietly looming. For tens of millions of years, dinosaurs ruled without rival, shaping their environment and reshaping themselves. And yet, the golden age of dinosaurs wasn't invincible. The Cretaceous was a time of incredible innovation, but no amount of biological brilliance could have prepared these creatures for what was coming. We often think of the dinosaurs' extinction as an ending, but in many ways, their story and their place in evolution was just beginning. Moments like these, where success reaches its peak, carry an inevitable tension. What happens when a thriving planet is suddenly thrown into chaos? What happens to the kings of Earth when even the ground beneath them seems to betray them? With everything so perfect on the surface, it's strange to think about how delicately balanced these ecosystems really were. This was the height of their reign, sure, but it was also the calm before the storm. And the storm that was coming wasn't an ordinary one. It was cosmic. The day the dinosaurs fell. In the span of just a few hours, 160 million years of dinosaur reign began to unravel. It started with a single, fiery impact. About 66 million years ago, a massive asteroid, roughly the size of Mount Everest, slammed into Earth at a speed of over 60,000 kilometers per hour. The point of impact? What is now the Yucatan Peninsula in Mexico. The force of the collision released energy equivalent to billions of atomic bombs, creating a crater over 150 kilometers wide. For a moment, the sheer violence of the event redefined the surface of the planet. The immediate effects of the Chicxulub asteroid were unimaginably destructive. The Earth below liquefied upon impact, with shock waves rippling across continents. Forests thousands of kilometers from the site ignited instantly. The surrounding ocean surged in violent tsunamis, throwing walls of water that swept for hundreds of miles. Vaporized rock and sulfur were launched skyward, punching through the Earth's atmosphere. If you could have stood far enough away to witness the moment, though nothing living within view could have survived, it might have seemed like the entire horizon had erupted into flames. But the planet-wide disaster didn't stop with fiery clouds and burning landscapes. Trillions of tons of debris turned into a dense layer of particles, spreading through the atmosphere. Within hours, these particles began to block out sunlight, casting the Earth into an unnatural darkness. Temperatures dropped sharply as sunlight, essential for plant life, was drastically reduced. Meanwhile, acidic rain poured from the skies as sulfur mixed with water vapor, poisoning soils and rivers. What followed was something paleontologists compare to a nuclear winter, a world with little warmth, very little light, and collapsing ecosystems.
At the heart of this unraveling was the disruption of a food chain that had sustained the dinosaurs for millions of years. Without sunlight, photosynthesis ground to a halt. This meant the plants that herbivorous dinosaurs like Triceratops and Edmontosaurus relied on died off quickly. With the disappearance of plants, the vast herds of herbivores began to starve, one by one. And when the herbivores fell, so too did the predators who hunted them. Dinosaurs that had once thrived by adapting to different climates and diets suddenly faced shortages they couldn't escape. For animals as massive as a Tyrannosaurus rex, which required vast amounts of food to sustain itself, survival simply became impossible. It wasn't just size that worked against them. Large dinosaurs also reproduced slowly. Most laid large, vulnerable eggs, and it took years for their young to mature enough to contribute to the population. In contrast, smaller creatures like early mammals or birds reproduced quickly and matured far faster. For the dinosaurs, losing multiple breeding cycles during the environmental collapse was catastrophic. There was no population recovery, no chance to adapt to the rapidly shifting conditions. The chaos wasn't limited to the land. In the oceans, another disaster was unfolding. The lack of sunlight wiped out plankton, tiny organisms that formed the very base of the marine food web. Without plankton, creatures like small fish and other sea life struggled, and in turn, the larger marine reptiles that relied on them, like the mosasaurs and plesiosaurs, vanished. Coral reefs, already fragile ecosystems, collapsed completely. The oceans, which had once been vast hunting and breeding grounds for countless species, transformed into a graveyard. In total, it's estimated that around 75% of all species on Earth went extinct during this mass extinction event. But even as the majority of life succumbed to these brutal changes, some creatures managed to endure, holding on in the shadows of a dying world. Survival, it turns out, came down to a few critical factors: size, adaptability, and how much food you needed to get by. Many of the survivors were small animals, ones that didn't require huge amounts of resources. Early mammals, for example, were able to stay tucked away in burrows or crevices, waiting out the worst of the environmental collapse. These tiny creatures could survive on meager food sources, scavenging for anything still edible. Meanwhile, some reptiles, amphibians, and fish persisted in similar ways, relying on detritus, the remnants of organic material, as their source of energy. Birds, the descendants of small feathered dinosaurs, also seized their moment here. Their small size, rapid reproductive cycles, and ability to eat a wide variety of foods gave them a tremendous advantage. Unlike their larger relatives, birds needed fewer resources to survive, and some could remain mobile, flying to regions where the devastation wasn't as severe or where patches of vegetation still clung to life. It wasn't just their feathers, it turns out, that helped birds make it through. It was their adaptability, their energy efficiency, their evolutionary flexibility. Not every region of Earth was a complete wasteland during this time. Some areas may have temporarily escaped total devastation, small patches where plants continued to grow or where life rebounded faster. But even in these locations, the environmental ripple effects were unavoidable. For most of the dinosaurs, even those that might have survived the initial aftermath, extinction became a slow but inevitable process. Populations dwindled, food sources disappeared entirely, and these beings that had defined Earth's ecosystems for so long disappeared, leaving silence behind.